In the previous lecture, we started with chemical reactions of alcohols and phenols. There we discussed about that alcohols may act as a nucleophile, it may act as an electrophile. Like if we see this, this is an alcohol molecule and here is an electrophile. Because oxygen is electron rich species carrying two lone pairs on it, that is why it will be acting as a nucleophile and will share its pair of electron with the electrophile and will be making this kind of bond with the electrophile. Here oxygen become positively charged because it has shared its electron with the electrophile. Now this pair of electrons shared between oxygen and hydrogen will be coming back to oxygen because it's highly electronegative atom carrying a positive charge. That is why it will take this pair of electron, while hydrogen will be released in form of hydrogen ion, and that's how the reaction is taking place. So here we can well observe that alcohol is acting as a nucleophile. Now what about if alcohol is acting as a electrophile? Alcohol may act as an electrophile also, but in the protonated form. Protonated form in the sense, like here we can see RCH2OH, RCH2OH. Now when hydrogen ion is coming to it, it will protonate it. So oxygen is carrying now only one lone pair with a positive charge. Now when this protonated alcohol come in vicinity of a nucleophile or is attacked by a nucleophile, the pair of electron present on the nucleophile will be shared here, and this pair of electron will be given to oxygen to neutralize its positive charge. So that's how this entire group will be removed in form of water, and we will be getting this type of compound. So this is all about the types of reactions given by chemical by alcohols. Now we are doing a very important property, that is acidic nature of alcohols and phenols. Acidic nature of alcohols and phenols. We know it very well, we studied in the junior classes also, that any acid will react with a metal to liberate hydrogen gas. So same is expected from alcohols and phenols also, and they do so. Like ROH, this is an alcohol, it reacts with sodium metal to give RONA plus hydrogen gas. So this is sodium alkoxide. Sodium alkoxide is formed and hydrogen gas is released. Hydrogen gas is released. If we balance the reaction, it has to be like this. Sodium alkoxide. We should pay attention to that the other acids also do the same, like HCl that reacts with zinc to give ZnCl2 plus hydrogen gas. So what I'm trying to tell here, that because just like the other acids, alcohol is also liberating hydrogen gas on reacting with active metal. That is why we can say that this is acidic in nature. We may take another example. Say for example, we have this compound. This is tertiary butyl alcohol. This reacts with aluminium to give this compound. CCH3, CH3, CH3O, whole thrice Al. This is aluminium tertiary butoxide plus hydrogen gas. We should not get confused with this, that how is it whole thrice. This is just to balance the valency of aluminium. Similarly, phenol also react with metals to liberate hydrogen gas. This is phenol, react with sodium to give sodium phenoxide and hydrogen gas is liberated. So this shows that phenol is also acidic in nature. Sodium phenoxide is the compound formed here. So this is one property shown by acids, and it's also shown by alcohol as well as phenol. That is why we can say that alcohols and phenols are acidic in nature. If we pay attention to other properties of acids, that rest of the acids, they own reaction with bases, like NaOH is a base, and any acid reacts with a base to give salt and water. That is what we studied. So is the same thing happen with alcohol and phenol also? If we do the same thing, that is ROH, and if we do its reaction with NaOH, no reaction takes place. No reaction. no reaction. While if we do the same reaction with phenol plus NaOH, the reaction will take place just like other acids do. It is ONA plus H2O, again sodium phenoxide plus water. So we should understand here that the first property that acids react with metals like alcohol and phenol, they reacted with the active metals to liberate hydrogen gas. So same story happened in case of alcohols and phenols. So this shows that both are acidic in nature, but alcohol that doesn't react with a base to give any salt and water, while phenol that react with a base to give salt and water. So here we can conclude two things. One is alcohol as well as phenol, both are acidic in nature. Now alcohol that doesn't react with a base to give salt and water, while phenol do so. So what does it show? That alcohol is a weaker acid. Alcohol is acidic, but it is a weaker acid than phenol. So this is the conclusion which we can draw from these reactions. Now how can we explain the acidic behavior or acidic character of alcohols as well as phenols? So that we will discuss here. This is very, very important. Before discussing about the acidic character of alcohols and phenols in particular, I just want to discuss about the two criteria for any acid to be acid. One is acidic strength of any acid, or you can say whether a compound is acidic or not, that depends upon the furnishing of hydrogen ion. If any compound furnishes hydrogen ion or dissociate to give hydrogen ion, it means that has to be acidic. Then next is that after release of this hydrogen ion, whatever the anion left, or if you go for a pure chemistry language, we will say that whatever the Bronsted base left, after loss of a proton, whatever the Bronsted base left, that should be stable. So anion or Bronsted base should be stabilized. So these are the two criteria which make any acid as acid. Furnishing of hydrogen ion, the compound should furnish hydrogen ion, then we say it is acidic, and anion or Bronsted base formed should be stabilized. So these are the two criteria for any compound to be acidic. So let's see, does it happen in case of alcohols and phenols? ROH. Here ROH will dissociate to give RO, that is alkoxide ion with a negative charge, and hydrogen ion. So this is the Bronsted base formed and hydrogen ion is furnished. So this is alkoxide ion formed. So first condition is fulfilled, that hydrogen ion should be released, or you can say proton should be given out. So that is given out by alcohol, and this shows again, or this supports that why alcohol is acidic in nature. But why hydrogen ion is furnished? That furnishing of hydrogen ion, that depends upon the polarity of oxygen-hydrogen bond. Polarity of oxygen-hydrogen bond. Here oxygen is highly electronegative, that is why it will withdraw this pair of electron towards itself, and this will insist the hydrogen ion to go away. So that's how the hydrogen ion is furnished. Now on this basis, so what do I mean to say? Great polarity of oxygen-hydrogen bond is the basic reason for acidic character of alcohol. So higher is the polarity of OH bond, higher polarity of oxygen-hydrogen bond, it means weaker bond. Weaker bond means stronger acid, because easily the hydrogen ion will be furnished. So that's how we can discuss about it. So on this basis, we will try to discuss about, or we will try to compare the acidic character of primary, secondary and tertiary alcohols. Let's take example. Say for example, we have methanol or ethanol, CH3, CH2OH. So this is a primary alcohol. Then this is a primary alcohol. Then the next is we are taking a secondary alcohol, that is CH3, CH3OH. This is a secondary alcohol. Now let's take a tertiary alcohol. Tertiary alcohol is CH3, CH3, CH3OH. This is a tertiary alcohol. Now in this case, if we talk about the primary alcohol, oxygen hydrogen bond is polar, so that is why this hydrogen ion will be released easily. Now what about the secondary alcohol? In case of secondary alcohol, there is a electron releasing group. This is again an electron releasing group. So this electron releasing group will increase the electron density on this carbon. In turn, it will increase the electron density on this oxygen, which will decrease the polarity of oxygen hydrogen bond, and that's how it will decrease the acidic character. So here, because of the plus I effect, polarity of oxygen hydrogen bond decreases. Oxygen hydrogen bond decreases, and that is why that furnishing of hydrogen ion becomes difficult, and that is why it is a weaker acid. Now what about the tertiary alcohol? In tertiary alcohol, there are 3 electron releasing group, so maximum plus I effect will increase the electron density on this oxygen maximum. That is why this oxygen hydrogen bond here will be minimum polar. Minimum polar means it is a stronger bond. Stronger bond means hydrogen ion will be furnished with great difficulty. So what is the order of the acidic character of the various types of alcohols? The order of acidic character of various type of alcohols is, that is, primary is maximum acidic, followed by secondary, then tertiary. This is the acidic character or acidic strength. So tertiary alcohols are the weakest acid. Now one more interesting thing I'm going to add here, that say for example, if we talk about alcohol after releasing of this hydrogen ion, this is the Bronsted base left. Now if it reacts with water, you see this water will become a proton donor here. So it is ROH plus OH minus. So here you should observe that this is acting as an acid. So what does it show? That water is a stronger acid than alcohol. Water is a stronger acid than alcohol, or what I'm trying to tell here, alcohol is a strong acid, alcohol is a weak acid. It is weaker even than water, because here you can see that this is accepting proton while this is donating proton. Why is it so? How can we explain it? Like if we see alcohol, in case of alcohol, there is an alkyl group, whether it is primary alcohol, secondary or tertiary, at least or minimum one alkyl group will always be there. So it will increase the electron density on this oxygen, and that's how will decrease the polarity of oxygen hydrogen bond. And the polarity of oxygen hydrogen bond is less, it means bond is stronger. Less polar, stronger. Less polar, so bond is stronger. Bond is stronger means it is a weaker acid. Now if we see water, in case of water there is no electron releasing group. That is why oxygen hydrogen bond is more polar, and that is why it is a weaker bond. Weaker bond means it is a stronger acid. Weaker bond, stronger acid. So that's all about the acidic character of alcohol, the comparison of acidic character of various types of alcohols and comparison of acidic character of alcohol and water. Now in the next class we will discuss about the comparison of acidic character of alcohol and phenol.